Is it recording? Okay. Good morning, guys. Welcome. I'm glad to see you all today. For today's assignment, we're going to be looking at number 11. It's called quadratic functions and their graphs. We covered quadratic functions like way in the beginning of, at the end of MP3, like right before spring break. So we're going to go over some stuff to refresh your memory, and then we're going to keep covering this. This week we have our 4-week exam tomorrow, Wednesday, but you'll start with this, and then you'll cover it next week. We're going to describe graphs of quadratic functions of the form f of x equals x squared plus k. So what this means is when we talk about functions, all we're talking about is that it's going to have this little f of x notation. Sometimes you'll see h of x. Sometimes you'll see g of x. All this is, it's the name of the function, okay? And the function is just like a math equation. It's kind of giving us some instructions or telling us what we need to do. But don't get worried. Everybody else gets lost with functions, okay? Function is just a math equation, but instead of writing y, the letter y, we write f of x, okay? Or h of x or g of x. F of x is the same as y. It's exactly the same thing, okay? So that's one thing just to keep in mind. And right now we're going to see the graph of x squared when we add one constant to it, okay? The question we should be asking ourselves is, what is a function and the vertical line test? That's how we're going to tell if it's a function or not. We will describe graphs of the form f of x equals x squared plus k, and then you all will sketch graphs of quadratic functions and label the vertex. If you didn't get a chance to write this down, it's okay. I'll post a video and you can copy it from that later. So I'm going to go a little bit fast today. Let's define and explore a few things first. Functions and the vertical line test, okay? We're going to figure out what is the vertical line test. It should sound familiar because we've covered it before in this class, and I'm sure you've covered it in algebra or other classes, okay? But there's a quick way, when you have a graph or a picture of a graph, there's a very quick way to tell if it's a function or not. All a function is, one of the definitions is that the x's don't repeat, okay? If you have like the same x twice, then it's not a function. And the way to tell that visually is by graphs of functions past the vertical line test. So see this graph right here, this parabola? I'm going to highlight it here in blue. Oops, I didn't quite capture it. Okay, we're going to highlight this function in blue. This is the quadratic function x squared. The vertical line test is, let's say you draw an imaginary line. An imaginary line. What's up, Santiago? Come on in. Why does it keep doing that? If you draw an imaginary line up and down, I want this color, and it only crosses or intersects with one value of x, then it's a function. The other way you can do it is think about like getting a pencil or a pen and going from left to right and going like across the graph. Okay? If that line only intersects with one point on the graph at any point, any x value, okay, then it's a function. Okay? Since these lines do not intersect with more than one point on this blue graph, it is a function. That's all the vertical line test is. Okay, so this red line right here, see how we draw a line up and down? It's only intersecting with our graph at one point. That means it's a function. That's what the vertical line test is. You may be asked to do this on the final. I don't have the final from last year, so I'm not sure what exactly they're going to ask you, but you might need to know that. Okay. Remember the graph of the quadratic function f of x equals x squared. So remember I told you guys that f of x is the same as y. Okay, so instead of writing f of x, I'm going to write y. And I need to know how to graph this. Eventually, at some point, you guys will use calculators. But for today, I need to show you guys how to use it from a table. So here's how we're going to do it. You're going to make up a table for x and y. So start with this, and you guys should be writing this down in your notes. X and y. For our x, we're going to pick x. We're going to just pick random numbers, okay? There's a certain random numbers we need to pick, but I'm going to tell you which ones. So always pick a negative number. Let me do this. -2, -1, 0, and then a positive number. And we're going to do 2. If you always pick these 5 numbers, you'll get a pretty good idea of what the graph looks like. If you pick different numbers, you can if you want to, but it'll mess it up. It'll make it harder to graph. Okay. So if you always pick -2, -1, 0, 1, and 2, That should be pretty straightforward, okay? These are just, they're not going to be given to you in a problem. So if you see a problem like this somewhere in a test or on the 9-week, on the comprehensive final, they're not gonna give you that. You need to make it up on your own, okay? You need to create this, unless they let you use calculators. Come on in, guys. So what you're gonna do is you're gonna substitute this -2 into the equation, okay? -2 squared equals 4. Okay, let me put it in a different color. Let me zoom in a little bit. Okay, guys, come get a note sheet from the blue basket. Let me put it in blue. So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Does that make sense? So all I did was I substituted these x values into the equation, right? So I did -2 squared, -1 squared, 0 squared, and 2 squared. Does that make sense? And that's how I got this 4, the 1, the 0, 1, and 4. Okay, remember, when you square a negative, it becomes a positive. Negative times a negative is a positive. And then what you do is you plot these coordinate points. The reason I wrote x and y is because these are coordinate points. Okay, so I go to -2, 4, -1, 1, 0, 0, 1, 1, and 1, 4. Okay, those are my points, and now I'm able to plot my little graph of x squared. Okay, that's the parabola x squared. It's always going to be that. It will not change. So what we're looking at today is we're looking at something called transformations, or when we say shift left, right, up, and down, we're saying what we're talking about is this is our reference. Y equals x squared. Our vertex is 0, 0. So let's write that down because we need to know the word vertex. Okay. There's going to be 2 words we need to know. Vertex. Okay, this is your vertex. Your vertex is either the very lowest point on the parabola or the very highest point if it's a downward facing parabola. And we'll see some examples of that in the practice. So the vertex is like the bottom or the top. Okay, so if this is like a U, it's the bottom of the U, the very lowest point. And then the other word that we need to know is axis of symmetry. Okay, what does symmetry mean? You know what symmetry means, Nick? Christian? What does symmetry mean? Do you know, Amber?
Like the same.
Symmetry is like the same. What does it mean, Gio? The same on both sides. So if like you cut something in half, okay, it's going to be the same on the left as it is on the right. And this is called, let me write it here, axis of symmetry. Good job, thank you. Okay, it's the imaginary line that's going to cut that parabola in half so that it's the same on the left and the right. Are there any questions so far? This should be kind of familiar. We've covered it before. I know we've covered it in this class, and you should have seen it in other classes. All right. Here's some more definitions. Now we're on this little section that says, let's see some examples of graphing the parabola defined by f of x equals x squared. Now remember, we have our x squared. We know what this parabola looks like. We just graphed it. Now we're going to have this plus another variable, another constant, another number, okay? So all it's going to be is we're going to do the same steps. We're going to substitute numbers in, but now we're just going to have to do an extra little addition, okay? But there's some rules here. There's 2 rules there's some rules that will help us simplify our answers and know how to determine if we're going to have a shift up or down just by looking at this number here, okay? So whatever this number is, it doesn't matter, 4, 5, 6, 0, or 1, 2, 3, 4, 5. If it's positive, then that graph moves from 0, 0 up however many this number is. So you need to fill in this, I think. Fill in positive.
It's where it says upwards in the bottom.
Okay, and you have to fill in upward.
It goes for the.
You have to fill in upward. Okay, so if it's positive, the graph of x squared is going to shift upward. Okay, so it's going to move in the up direction. If it's negative, oh my gosh, what's going on here? What is up with these little lines? Okay, if k is a negative number, then the graph is going to shift down from 0, 0. Okay, so I believe this is what you need to fill in. Fill in the blank here, downward. Okay, make sure y'all write that in. Yes, sir. Right now, we're almost done. Let me get through the example so that I make sure that you guys got it. Okay, and we're going to see simply, without even graphing, we can tell where the vertex is without even graphing. It's always going to be 0, and then whatever the number of k is. It's always 0 first, and then whatever the number of k is. And the axis of symmetry is always going to be the y-axis. So when you have this case, the x squared plus x, the graph is always going to stay like centered in the middle at the 0, 0, but it's going to go up and it's going to go down, and then that's it. Okay, so let's take a look at some transformations, as we call them. We're going to be here on example number 1. We already know what x squared looks like. I already told you. It is, we're going to do a table. Simply use some numbers. Always use these 5 numbers. It will be the easiest way to graph. Okay, and so forth and so forth. You guys should remember the steps because I just showed you on the previous slide. It's always going to be 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay. So what happens is, what's going to happen here? Let me use blue. This one's x squared, so we're going to have this as a start, but what's going to happen to the graph? Is it going to go up or down?
It's gonna go up.
It's going to shift up because of this positive 5. Okay, so let's see what that looks like. I'm going to try to move out of the way here. Same numbers, same substitution, except instead of doing a little baby one, we got to do a little bit more, an extra step. Okay, so look, it's still negative 2 squared is 4, plus 5, God, I'm too fast in my brain, equals 9. Does that make sense? Negative 1 squared plus 5 equals what? That's 1 plus 5 is 6. 0 plus 5, start to see a pattern here. 1 squared is 1 plus 5 equals 6. And what do you think this 2 is going to be? 2 squared plus 5 is what? 2 squared is 4 plus 5 is 9. Are there any questions? This is usually where I lose people. You're good with this? Where we got this 9, 6, 5, 9, 6 from? So now we're going to plot this. Negative 2 and 9. Negative 2. I'm kind of running out of space, but look. 6, 7, 8, 9. I can kind of like fill in the blanks here. So I got negative 2 at 9. I've got negative 1 at 6. I've got 0, 0 at 5. Oops. Okay, so I'm just plotting these. 1 at 6, 2 at 9. Okay. So we keep the same kind of shape. The only thing is, instead of being here at 0, 0, the whole vertex and the graph shifted up 5 spaces. Okay. Plus 5 went up 1, 2, 3, 4, 5 spaces compared to this one. Does that make sense? Okay. Yes, you can go to the bathroom and take the class. Or did you have a question about this? What's up?
How come like the negative 1 is squared and the 2 is squared?
It is squared. I just didn't show it.
Oh.
Because look, 0 squared is 0. 1 squared is 1. And then 2 squared is 4. So it looks like it's like the same answer, right? You square 0, it's always 0. You square 1, it's still 1. So it is squared. I just didn't write it in. I'll put it here so it's not confusing for people on the video. Okay, good question. That's actually a good question. It is squared. Okay, so let's talk about the vertex. The vertex is the lowest point, and remember, we want to write the vertex as a coordinate point, which means this, 2 points, and then this. So what's the x is 0 and our y is 5. So we're at 0, comma 5. Okay. Remember I told you that rule. It's the vertex for these kind of parabolas is always going to be 0 and whatever that number is. Okay. So we don't always have to graph it. If the question asks you the vertex, but it doesn't ask you to graph it, you can just use that little formula. Okay, let's look at example number 3. Now we've got x squared minus 1. Okay, so what do you think is going to happen to this one? Remember, x squared. I'm not going to write the table on this one. I'm going to show you, I'm going to just go from x squared because I know x squared is always this. If this is x squared, all of these points are going to go down 1 unit. They're going to go down 1 unit. Okay, because that's a -1. I don't need to do the table. I already know for sure everything here is going to go down 1. So that goes down 1. These go down 1. These go down 1. These go down 1. These go down 1, and that's my new graph. Does that make sense? Okay. So in the black is your x squared. In the red is your x squared minus 1. We go from this 0, 0. Everything shifts down 1 unit. Okay. So now you can see there is a couple ways to do it. You can write the table, substitute into the equation, and get your values for the coordinate points. Or now that you know the kind of the trick, all you know is that all these points are going to shift down 1. For some of the more complicated problems that have what we're going to do next week is you'll see now we add other numbers. So it's going to be x squared plus something in a parentheses, and then after that we're going to add another number and then another number to have a whole long equation. There are certain things that make the graph go up and down. There are certain positions, if you put the number in a certain spot, it makes it go left or right, and then there's other ones that make it get really skinny or really large. Okay. Are there any questions on these so far?
Are you gonna check this semester?
You're gonna put it in your notebook, okay? And then, so I'm gonna leave your notebooks. I'll leave all that stuff for Miss Escobar, and then you'll still keep putting this in your notebooks. And however she's gonna check, I told her I usually would do it on Fridays, where I would check all your whatever assignments for the week. But it's gonna be up to her how she's gonna check. This one and the 4-week exam, I don't put those grades in as the last grades. Okay, so just put it in your notebook for now. There is some practice problems. Let me see here. I gave you 3 little baby practice. 1, 2, 3. Okay. You guys should be able to figure these out based off the examples. Actually, I only gave you 2. Did I give you 2?
Yeah.
Okay, so 2 baby practice. If you're stuck, let me know. I'll come by and help you. It should be pretty straightforward. Some of these, I forget what was on the final exam for last year, but remember, that comprehensive final, I didn't make that one. That comes from EPCC. You're going to get it at the end of the year. I have no idea, I have no choice or what is on that test, but you do have to take it at the end of the year, okay? And it is part of the requirement for this class that you pass that final, okay? So we'll cover the rest of this stuff after next week. Ms. Escobar, I gave her a schedule of what to cover and what days, and then the last week of May, you guys are going to review, you'll be doing review for the whole week from semester 1 and semester 2 to help you get ready for the final, okay? And then that'll be it. Yes. If y'all have questions, let me know. Other than that, we'll get through today. Tomorrow, let me find out where we're going to be tomorrow. What's up? How you guys doing? You guys doing all right so far? You doing good at what? To where? Why? You can't do it here. God dang, tell that lady to quit being so ruthless. I know, man. What's up, Denise? How was your weekend? Good luck. Try to knock it out. That we can get out of here. You're welcome. Shoot, I gotta put that on. Turn it. See what I can't do stuff. I can do stuff.